start us off, if that's okay. Welcome, everybody, to the latest episode of Golang Live, part of the live series over at Amicus Recruitment. This episode is titled How to Build Serverless Applications Using AWS and Golang. My name, for those of you who don't know me already, is Jake O'Regan. I am a Golang recruitment consultant over at Amicus Recruitment. I specialize in recruiting for Golang engineering professionals to companies across Germany and also remotely around Europe. As an agency, we also cover London and Amsterdam. I'm delighted to be joined by Robert this evening. Robert is the engineering team lead over at epilot in Germany. He's also a cloud and Golang expert himself. So I just wanted to let everyone know before I hand over to Robert, tonight's episode will be recorded and everybody will receive a YouTube link to the recording. If there is something that you miss and want to go back to, then that's no problem. It should last between sort of 30 and 45 minutes or so, roughly. Then I think sometimes these things can go over or under, so we'll use that as the basic guide. And also, if you have any questions, please do use the Q&A underneath as we go along. We try to keep it as interactive as possible, but then also there will be a chance at the end for Robert to answer any questions as we go through. So without further ado, Robert, over to you.
Awesome. Thank you very much, Jake. Thank you everyone for coming. I'm very excited to be here today, and I really appreciate the opportunity. I'm extremely grateful. It's hard to find webinars or opportunities to speak to the public these days. So as Jake already said, my name is Robert Tingirica. I have almost a decade of experience designing and building distributed systems, mostly in the cloud. I have offered consulting services to some of the biggest players in the automotive and telecom markets, and now I'm working here at epilot as an engineering team lead. We use AWS and Serverless in order to build solutions for our customers in the energy sector, and our goal is to make everything online as easy to sell as a pair of shoes. So yeah, if you're interested in this, if you want to get in touch with me, here are my credentials. We are also hiring. So now let's get started. Yeah, so today we'll be having a look at how to create serverless application using serverless framework and Golang. So the purpose of the API we are writing is to be used in a software as a service application. So the presentation should be a basic guideline on how to get started. I'm not going to go too deep into each of these topics, but as I said, if you have more questions, feel free to get in touch, write comments, questions, and I'll be happy to answer them. So yeah, without further ado, let's go into it. So what is serverless? Well, serverless means different things to different people. At its core, it means running code in a pay-as-you-go model. So on other people's computers or servers without caring about scale and some other things. So getting that as a service. In this presentation, we're focusing specifically on functions as a service. So we are not going to discuss containers as a service. That's a whole different topic. But again, as I said, if you are interested in that one, feel free to show your interest. So here's the confusing part. We are using something called serverless framework, which has serverless in the name, but it's kind of different than the concept of serverless. In some environments, including our workplace, we say serverless and people assume we mean serverless framework. Sounds confusing, but it's really not. Bear with me. All right, so a little bit about the tools we are showcasing today. So we'll be discussing about Golang and building a serverless application in AWS. We will be using serverless framework for the orchestration or representing our resources as code, and also abstracting from some of the complexity that comes with representing all of these resources inside of the cloud. For this project, I am using GitLab CI for deployments, for CI/CD, for testing, all of those things. I am not showcasing that in this presentation, but if you are interested, feel free to get in touch. I'll be taking advantage of Amazon Lambda as our main runtime environment. And yeah, this is basically where the FAS comes in. So functions as a service. All right, so why use Golang? Well, Golang is static typed, which is amazing for development experience. Not only that, but it also has strict rules in place that force the developer to write cleaner code. Unused imports, for example, lead to compilation errors. Unused variables are caught at compile time. And also this reduces the feedback loop tremendously, which basically translates into a better development experience. It also comes with a formatter out of the box. So you don't have to think about how the code should look like. This cuts out a lot of the conversations around topics such as tabs versus spaces. There's one way of doing things, and that's the correct way of doing things, basically. That simplifies a lot. Other ecosystems offer this, but you have to go through the hassle of setting up everything. Third-party tooling is also very opinionated. So again, you get these discussions where people have different opinions coming from different backgrounds. That gets hard when you deal with multiple developers, a large company, multiple teams that want to do things differently. And it's way easier when all of these questions have been answered for you. So also, because you have all of these checks in place at compile time, this makes the code easier to read because you're writing it cleaner by default. Alrighty then. So why not use Golang in such an environment? Well, in Amazon Lambda specifically, you have certain features such as the code editor. So shouldn't Lambda be used with interpreted languages? Maybe if you're getting started, this might be a good tool to prototype something out. But the more you adopt the cloud, the more you learn to represent resources as code. So you wouldn't make code changes in production before going through all of the quality gates. And also in other environments, it's basically a good practice to make sure that you represent them and deploy them as close to production as possible. So I'm a big fan of writing even POCs as code, and this is extremely easy to share, and also it's easier to expand on that idea without doing duplicate work later down the road. So things like this tool to me are not as important, but if that's something you care about, yeah, take that with a grain of salt. Okay, so getting started with serverless framework. How do you do that? Well, it's very simple. All you have to do is execute this one command, and yeah, you can get started with the project right away. You can see over there that we're executing SLS create. We're specifying the template, AWS Go mod. The AWS part is the cloud provider. The Go part is the Golang part. Mod stands for modules because we're packaging the code as a Golang module. And then the path is the directory where we want to create this. Cool. And then we end up with this directory, with this file structure in there. And yeah, let's go a bit more into details on how that looks like. So this is the directory structure. We end up with a make file. So we run make and build the project, simple as that. Go mod sh is the helper script to work with make. So all of those commands actually end up in that script. Hello and world are the important directories over here. These are the two endpoints and the handlers for the Lambda functions that we are writing. So each one has a main package and is built individually. So this means that you end up with different binaries, as we will see later down the road. Serverless YAML, here is the serverless framework, and this is what the serverless framework uses to orchestrate the application. So all of our configuration goes in there. The serverless YAML is syntactic sugar, basically, because everything gets translated into CloudFormation. So we'll go through it in a minute. Now, each handler, as I said, is represented in a main package. It is built as a standalone binary. Importing all of these dependencies, including the SDK event types and the Lambda handler necessities and all of that stuff, happens at the top. But what happens lower down? Well, then we get all of this thing, the second section of our package, which is the code itself. And as you can see, there's not much to it, but let's dive a little bit deeper into it and try to understand what's going on. First, we have the function signature. As you can see, the context that is normally passed to a Lambda function is the only argument that we're using over here. For example, if we are using this Lambda function to handle a post HTTP event, then we would add a another argument in there, which would be the request, but we don't need that now. So yeah, then we return these two types, which is a response. As you can see, that's sort of an alias for events API gateway proxy response, and also an error if that it really is the case. All right, so what is this context object? Well, if you're not familiar with it, this is sort of a way in which the function knows things about itself, so you can consider it as metadata. So inside of AWS, you will get access to something like the function name that you get deployed, the function version, memory limits, the log group name, and various other things. You also get something called an AWS request ID, and this identifier identifies the invocation request. If you were to use authentication, here's where you would look for that. So for example, mobile applications that might do API calls to API gateway, and then that API gateway event gets handled by a Lambda function. All of that information about Cognito identity would be in this object right here. Right, so what's next? Well, then we actually do our magic. So here is where our logic goes. So we have a buffer, we marshal a map that has a key string and an object that can be anything. In this case, represented by an interface. Generally, here you will have your own types that you declare based on whatever your requirements are. And yeah, if there's an error with the marshalling, we return. If we are good, we go on. So then we get that HTML escape thing that if you're familiar with Golang, you know what it means. If you're not, basically that's a way in which to encode the script so that the browser can load all of that information inside of a script tag safely, I believe. Right, and at the end of the handler function, we have the response. If everything was okay, we return the response in the type of the API gateway expects. So this is our response type that we defined earlier. We can see that we need the body, the status code, but we can also pass in some optional information like extra headers, for example. So what's next? Well, here is where the magic happens. So we have our main function, which is the most important function inside of our package. And in there, you can see that we're actually using this SDK and the function called start from the Lambda package inside of that SDK with the handler we defined above. So this is how all of this ties in together. So this is where the Amazon magic happens so that you can actually execute your binaries inside of that runtime. Yeah. All right. So what about adding extra information like initializing variables? Well, you can do this like you would normally do this inside of a Golang project. You would call the initialize function that executes before the main function executes. So what if we were to if we had the necessity to get an SQS URL, for example, how would we do that? Well, let's have a look at this init function in there and see how that looks like. If we zoom in a little bit, we can see that we have this PDF rendering queue URL, which is a variable that's declared globally. And then inside of the init function, we're actually getting the value for that variable from the environment variable. But this can also be fetched to SSM so that you can store all of that information in parameter store, which is ideal in a Lambda environment inside of AWS. All right. So now that we went a little bit through the code, how do we actually build the project? Well, we execute one command. Since we have that make file in there, we just run make. So as you can see, everything compiles in there. And we can see also the commands that have executed. Also, if we do a tree, we have a new directory in there with a couple of binaries. So let's go into it and see how that looks like. All right, so this is what we actually ended up with. As you can see, the binaries are compiled individually, as I mentioned. So there is one Lambda function per Golang compiled binary in this case. Since for post and get, you have different definitions, you can have different definitions inside of serverless.yaml. You can go even more granularly where you compile a binary per method per endpoint, but that's up to you. If you want to go that granular, feel free to do so. If you want to do checks inside of a single binary, if you have a get or a post, you're also free to do that. So we'll have a look at how the handler definition looks like in a minute. If you have experience with other Lambda runtimes, I think this might help to be like a good comparison, especially if you're coming from a interpreted language background. All right, so let's go into serverless framework. What's this YAML file all about? Well, at the top, we define our service name. Simple, right? Then we are mentioning exactly the version we plan on using for the framework, the serverless framework itself. Then we have the provider section. So here we configure the provider to be AWS, which means that we are using Amazon Lambda. This whole thing gets translated into that. And then the runtime is Golang version 1. The region is explicitly set. And then we move on to the next section. This section is very important. This defines the IAM permissions that we want to allow to the function whenever it runs. So this whole part over here gets added to a policy, that gets added to the role, that gets attached to the Lambda function. So you can see in there that we are free to use all of the cool things that we can use in CloudFormation. For example, ref and join and other functions of the sort. So there are more permissions added to this role that we do not see explicitly defined over here. That's basically magic that serverless framework does for us. But I think that's a little bit out of scope for this conversation. Okay, so in the same file, if we go a bit lower, we end up seeing this part over here, which is the package section. So as we saw after we ran make, we ended up with binaries. So this is usually not common for function as a service systems, or wasn't very common in the beginning when that became a thing, but now it's becoming a bit more widely adopted. Interpreted languages are usually more common over here because it's easier to handle that sort of thing. It might seem like using a compiled language with a fuzz system is a hack, but it's really not. And you get a lot of benefits by doing this. For example, the package size is way smaller than something like TS or Node.js. The footprint is actually extremely low in terms of memory consumption, so you'll end up paying less if you go in this direction. Speed is amazing. Everyone knows that Golang is fast. Cold startup times are pretty good. All of this, even though if you're familiar with AWS and Golang runtimes, this is running in Amazon Linux version 1. Version 2 is better optimized, and there are some runtimes that are running on version 2, but this is still extremely fast and sometimes even faster than the ones that are running on the newer Amazon Linux version. So yeah, I really think that Golang is extremely good for this purpose, running it in a fuzz system. Right, so moving on, we have the function definition section. Each function over here is defined for a specific endpoint path that we have in our application. So we do get on /hello, we run the first function. I think that's fairly simple. We can see the event section. We say that we want this to be an HTTP event, and this translates in serverless framework creating an API gateway for us. Once we get an HTTP call to this API gateway, our function gets invoked, and we only pay for the execution of that specific function invocation, however long that duration took. And yeah, add the resources that we have configured for the function on that, and that's exactly what we pay for, nothing less, nothing more. API gateway can have rules in place that make our life easier. Payload validation, throttling, etc. It's quite a powerful service if you can take advantage of it. Sometimes you don't even need code in place. You can translate the payload that comes in and just store it somewhere like a DynamoDB table without having any code execute. You can just proxy it through. Yeah, so as I said earlier, the same function can have multiple events, so you don't have to do the split by HTTP method here. It can be done inside of the code as well. So you can say, you can mention the same binary even though you're doing a get or a post for the same endpoint. And that's perfectly valid approach. So deploying the service, just by executing one command, we provide the stage name. Let me just click play over here. So just to clarify, the stage that we're passing in here is different than an API gateway stage. This basically gets concatenated to the name of the CloudFormation template that we are deploying, and then you end up with this full name of the application. So you can see the binaries are being packaged over here and uploaded to an S3 bucket that does not yet exist. So that's why you're seeing over there the creating stack first. That's what's happening. And then you see also update stack later. We have,
Sorry, Robert, can I just interrupt for 2 seconds, if that's okay?
Yes, perfect timing.
I just had a question come through, which is good. Thank you, Ravi Kumar, for your question. It is, what is the purpose of serverless YAML, for example? Why are the functions defined here when they are already defined in the Golang code?
Okay, so inside of the Golang code, we are defining the handlers. Inside the serverless YAML file, we are defining the Lambda functions. So the AWS resources inside of the cloud. That's basically what gets created inside of Amazon to make sure that we have a runtime where to run our code. So that's basically the difference over there. Imagine if you had a simple jar file, or I don't know, another application, another binary. In order to run that on top of a server, you need the server to be defined. So you can think about the orchestration part. So in this case, serverless.yaml. In this example that I'm giving a CloudFormation template that says, I want a server in the same way. So you're defining the runtime in there, and then you're coming in with the actual code, with the actual application to run on top of that. I hope that answers the question.
Absolutely, and there's just one more if I could. Thank you, Ali, for this question. If my backend is just is it CRUD operations on a database, is it worth to use Golang and Lambda performance wise?
Well, I think so. Depends on the amount of processing that you're doing in front of it. There are limitations with fast systems. For example, you are limited to the amount of time the Lambda function runs. That's a hard limit on 15 minutes. If you're doing all of that processing and then storing something, maybe not. Maybe also you could redesign the application. But generally speaking, yes, this is a pretty good approach. However, if we go back to the previous thing that I said about API gateway, it's also possible not to use code at all. If you just have HTTP, like a CRUD API, you're having operations done via HTTP, and then that information gets stored in something like DynamoDB table. Maybe you don't even need that Lambda function at all. You can just proxy it through using API gateway. Just managed services, no code in that regard. But this depends on your use case. Generally speaking, I think, this is a valid approach. I use this approach for the API that I'm showcasing over here. Works fairly well, performance-wise, scales amazingly, and is very cheap. All right.
So thank you.
No worries. So in the meanwhile, our application also finished, or the video that I recorded with the application being deployed. So as you can see, we end up with a couple of things over there, some pieces of information about our application. Let me just point over here. This is the package size of the whole application itself. So it's just 6 megabytes with 2 binaries, standalone, each one including all of the dependencies that they require in there. This can also be limited further, as I said earlier. The stack got updated and we ended up with 2 HTTPS endpoints over here. Note the S in the HTTPS endpoint. That's very cool. That's very important. So this is all done. Now let's try and call this application. Next slide, please. There we go. So now that we have these endpoints, we can actually use curl to call them. And we just do curl, specify the HTTP method, which is get, then make that verbose, and what do you know? It works. It's here at the bottom. That's the answer that we got from the server. Yay, success. Now, as you can see at the top over there, we are getting a certificate from ACM. So HTTPS is there by default. We don't have to think about that in this particular case. We also get some information over here with regards to the API, the headers that are coming from the API, including the Amazon specific headers like the request ID and the API gateway ID. All of this information is in there. And now if we call the second endpoint as well, just to check that it works. Great suspense. There you go. We got the message, 200 error code, everything's up and running. Great. So now we have our application deployed. So what's next? Well, here's where ideas can blossom. So let's say that we want to actually build a full-blown software as a service application. Well, what do you actually need for that? Well, we need identity management, something easy to use, something where our users can sign up, log in, all of that good stuff. Then we would go, in my opinion, with something close to home. And that for me would be something like Cognito. Then we need to store all of that information from the customers whenever they're using our application. So how would we go about doing that? Well, it might look something like this. We already have API gateway in front of everything. We might add Cognito for handling our users, as I mentioned earlier. Along it, we can enable the IAM authorizer so that we can authenticate and authorize all of the calls done to our API based on the our users logging into Cognito and exchanging those credentials for Amazon credentials. Then we have our runtime environment, which is Lambda, our Lambda function. And at the end, we have DynamoDB for storage. This is a perfectly valid use case that a lot of people use. In these sort of topics, AWS related, I'll be happy to go more in detail. I don't think that's the level of this presentation, but if you do want to, or if you do have questions about these topics, feel free to ask them in the chat or get in touch with me afterwards. I'll be happy to answer them. All right, so my recommendation whenever you're building something on AWS is to make sure you stick to these 5 principles. These 5 principles are coming from the well-architected framework from Amazon. Link is over there. They're basically operational excellence, security, reliability, performance efficiency, and cost optimization. There are questions and nudges in the correct direction in that guideline. So whenever you're going with Amazon managed services, you can use this, but some of the principles over there also apply to applications that are not running serverless on top of Amazon. So I still think that's a good read anyways. All right, so what about Golang itself? There's this cool article that I like about clean architecture, and I would encourage you to have a look at it. There's the link over there, have a read about it, but basically it involves using the onion pattern so that you structure your code in this way, so that everything is more pluggable, easy to read, easy to test, and easy to maintain. So I highly recommend reading this. But okay, enough about that.
Sorry, can I just one more question there, Robert, from Ravi Kumar again. Can the Golang serverless code be load balanced?
So if you mean load balancing so that you start multiple instances of the fast runtime so that you can handle multiple requests as you scale, you don't even have to think about that. So the Lambda function does all of that scaling for you. You can configure some things around it, but basically the answer is yes. But you just don't have to think about it. That's the nature of serverless. It will scale up and down as you need it. You don't have to think about, I have one function, so I need to start multiple instances of this function. This is the point of serverless. Hope that answers the question.
Thank you very much.
All right, so I would like to show you how this onion pattern might actually look like in your application with a little bit of dependency injection and some very lazy Golang code. given that we have picked DynamoDB for our database solution, I would like to include that dependency in and just show you how I might write this code. So it might look something like this. You could define an interface, and we have this cloud services package, inside of which we have declared the cloud data store service interface. We say that we want to get item, put item, and scan or search. You can name that however we want it. And those are the functions that our interface has. So over here, you could add your inputs and your outputs to the function signature. I was lazy, so I just got that from the, I'm just adding the DynamoDB stuff in there, but you could define your own data structures if necessary, if that's something that you want to do. Then if we move on, we have a data structure, and we have this cloud data store service data structure, and inside of it, we have one of the fields that is actually a DynamoDB client. Then if we look lower down, we have a factory method. So we return this cloud data store service interface mentioned above. And you can see that that's the return type over here. And this is the important part. We don't return this structure over here. We return the actual interface. So in the function, it actually instantiates the data structure that we defined earlier with DynamoDB client field. But if we look lower down, that implements the interface because we have this signature over here on top of that data structure. So this is one way in which we can do that. Basically, inside of Golang, in order to satisfy the interface, you can have any data structure that has all of the functions declared on the interface implemented. And here is where we actually do that. So this is perfectly valid. All right, so this way the factory methods allows us to return the data structure as it satisfies the interface now, but how do we make use of it? Well, inside of our handler function, we can have something like this. We can have our save client function that takes in a parameter called SVC. This can be our struct containing the DynamoDB client, but more importantly, this can be anything else that satisfies the interface because we are saying over here that this should be of this type. So this means that for testing purposes, I can just pass in another data structure that just returns something and never connects to DynamoDB. So that's one way in which I can test my code now. So yeah, up in the handler itself, we do want to pass the variable instantiated by calling the factory method in this particular case, but our handler can also be extremely clean. All of the logic now can reside in that other function, so we don't have to do anything else in here. So it's way easier to test our code in this case. For example, if we ever want to move away from DynamoDB, all we have to do is make sure that our new service implements the interface we have declared in there, and then it should be fairly straightforward to swap out. If we want to make changes to the service object itself, let's say if we're enabling distributed tracing, something like, and use something like X-ray, then we can do that in the other package and not even touch this. Alrighty then. So in conclusion, Golang works fairly well with Amazon Lambda, and serverless allows you to be extremely fast when it comes to prototyping. And then if you decide to take that on as an actual project, get it from POC to production, you can do that extremely easy. So why not try this in your organization today? All right. So that was it. Thank you very much. If you want to say hi, if you want to get in touch, here are my details. That's my GitHub handle over there, and that's my LinkedIn page. But now I'm going to hand it over back to Jake. Thank you very much.
No problem at all. Thank you very much, Robert. So we just had one question come through just then. It was, what drives the choice to choose Golang for AWS serverless applications over, say, JavaScript? Is it the speed or the availability of Golang resources, would you say?
So that's an interesting question. I have a couple of ideas to mention over here. First off, yes, speed is great. Second off is the static typing. I like catching errors fast. If I can catch something when I compile the code, I'll go in that direction. Then there's also this thing going on in the industry around if you can find Golang developers or if you cannot find Golang developers. Generally speaking, I am not a fan when I do hiring of looking at someone that's an expert on a particular language, for example. I look for problem solvers. And if this problem solver person can solve a problem with a specific tool, then I'm all for it. I want people to be able to adapt whenever I'm doing hiring. I think Golang works well with serverless. I think it's extremely fast. I think it's cheap. It's very easy to do development. My experience with it is great. So I would be willing to find resources, as mentioned in the question, that can adapt to my environment. Because Golang is not going to be here forever, just like COBOL is not here anymore, right? So people need to adapt to the future, and that's what I'm looking for whenever I'm hiring engineers.
Great stuff. Well, thank you. Does anybody else have any questions? I'll just leave it a couple of minutes, Robert, if that's okay, just to people to type any questions they may have. If not, like Robert said, he's very very contactable. You've got his details now. Feel free to reach out. LinkedIn. He's got his GitHub there. Feel free to get in touch. I will, as I mentioned, be sending this out to everyone via a YouTube link, so everybody will have access to this. If you wanted to remind yourself of Robert's details, everything will be on there via the link of this recorded webinar. Robert, thank you very much. That was brilliant. I'm sorry I speak on behalf of everyone. I say thank you. One question coming in. Sorry, just as we were about to close. Okay, so this is any recommendations for must-know serverless Golang resources, libraries, patterns, example projects, etc.
Well, architected framework, make sure you read that before getting started.
Yep.
Inside of Golang specifically, again, look at that clean architecture blog post. Other than that, make sure you trace your systems, make sure you do proper logging. Have a look at some other resources outside of Golang and try and adapt them to Golang if they're not there anymore. Like, for example, there are some good libraries for working with Lambda and logging inside of Lambda, inside of Python and Node.js. So yeah, explore. And if you find anything, also tell me.
Good stuff. Hope that answers the question. And I think obviously that we've given time to answer questions there, but thank you everyone for attending this evening. I'm sure I speak on behalf of everyone and say thank you to Robert. You were absolutely brilliant. Like I say, the recording will be available to everyone, but I think we'll leave it there. So thank you everyone for attending. Have a great evening, and we're free to be contacted. Either of us are. So speak to you soon.
Awesome. It was a pleasure. Thanks.
Cheers, guys. Thank you. Good night.